SpaceX is no longer a rocket company. The rockets were never the point. The real mission, the one capable of funding cities on Mars, runs on silicon, not fuel. There is a number buried inside SpaceX's financial model so large it makes Starlink look like a side project. A number built not from thrust or trajectory, but from data centers, artificial intelligence, and a plan to industrialize the moon. And right now, the pieces are already in motion. Every government space program in history shares the same fatal structural flaw. Apollo reached the moon. It was one of the most extraordinary achievements in human history, a technological monument that still echoes 5 decades later. But it ended, not because we ran out of ambition, because the funding did. Artemis is being built with the same architecture. Government contracts, political timelines, budget cycles that reset every 4 to 8 years. It is a flagship of scientific ambition, but it is not an economic engine. And here is the fundamental problem. A permanent human presence beyond Earth cannot survive on government funding alone. It requires industries. It requires revenue streams large enough to attract private capital at scale. It requires a business model that doesn't depend on which party controls Congress, or whether the public still cares about space next election cycle. SpaceX has always understood this, but the solution they've arrived at is not what most people expect. It has almost nothing to do with rockets. Starlink changed the economics of SpaceX in ways that weren't possible before. For the first time, SpaceX had a recurring revenue product, not just launch contracts, but a subscription service generating cash flow month after month. By 2024, Starlink had become a genuine business competing in consumer broadband across dozens of markets. But broadband has a ceiling. The global internet access market is a known quantity. There are only so many households, ships, and aircraft that need connectivity. Starlink will capture a significant portion of that, but the growth curve has a defined shape, and defined shapes have edges. SpaceX needs a market with no ceiling, a market where demand compounds faster than infrastructure can be built, a market where the hardware and logistics required to serve it overlap almost perfectly with the hardware and logistics required to establish a permanent presence on Mars. That market exists. SpaceX has spent years positioning itself at its center. The market is artificial intelligence, specifically AI compute infrastructure, the physical layer that makes machine intelligence possible at scale. And the collision between AI's appetite and Earth's physical constraints has created an opening unlike anything the space industry has seen before. In 2024, reports surfaced of a deep structural integration between SpaceX and XI, Elon Musk's artificial intelligence company. By early 2025, that integration had moved well past speculation into active operational alignment. The combination wasn't a simple corporate merger. It was a strategic alignment between two industries with overlapping infrastructure requirements, space logistics and AI compute. The numbers that emerged from that integration were striking. After combining operations, the entity began generating more revenue from renting computing power to AI companies than from rocket launches and Starlink subscriptions combined. Read that again. This isn't a side business, this is the business. And it reveals something important about the real constraints facing the AI industry right now. The limiting factor in AI development isn't models, it isn't algorithms or research talent. The limiting factor is physical infrastructure. The land, energy, and thermal management capacity required to run data centers at industrial scale continuously. Training a single large AI model can consume hundreds of millions of dollars in GPU time. Running those models in real time for users requires data centers operating at constant capacity around the clock. The demand for that capacity is growing faster than the infrastructure to support it. Every major technology company is locked in a race to secure data center capacity. Energy requirements are pressing against grid limitations across multiple regions. Land requirements are colliding with regulatory and geographic constraints that aren't getting easier. SpaceX looked at that bottleneck and did what SpaceX does. It looked upward. The physics of space-based computing address the exact constraints that are hardening into walls for Earth-based data centers. Solar panels in low Earth orbit receive uninterrupted sunlight for the majority of their orbital period. There is no night cycle limiting generation capacity the way terrestrial installations experience it. No land permits, no grid connections, no disputes with municipalities over power draw from an already strained regional grid. The thermal management problem, The single highest operational cost for conventional data centers is also resolved by the environment itself. Radiative heat dissipation in the vacuum of space is exceptionally efficient. Hardware that would require industrial chiller plants on the ground can shed heat passively through radiator panels in orbit. Communication between orbital compute nodes and between those nodes and ground stations runs through laser link networks, the same architecture already embedded across the Starlink constellation. For many AI inference workloads, the latency profile of orbital compute is viable for a wide range of commercial applications. The historical bottleneck has been launch cost and launch frequency. Getting sufficient mass to orbit to build meaningful compute infrastructure was prohibitively expensive on any timeline that made business sense. Starship changes that arithmetic entirely. A fully reusable Starship carrying 100 to 150 metric tons to low Earth orbit per flight converts every launch into an industrial cargo run. Not small satellites, actual server infrastructure at data center scale, delivered in volume. This is why Starship reusability is not just an engineering milestone. It is the economic prerequisite for an entirely new asset class. Every flight becomes a cargo run. Every cargo run builds more orbital compute capacity. Every unit of capacity generates revenue that funds the next flight. The flywheel, once turning, accelerates itself. Orbital data centers launched from Earth represent the first phase of this architecture. But the long-term vision extends further, off Earth entirely. The Moon is not only a scientific destination, it is an industrial site. Lunar regolith contains iron, aluminum, titanium, and silicon in concentrations accessible through established extraction processes. These are the same materials used to manufacture satellites, structural components, and electronic substrates on Earth. The raw inputs for the orbital data center network already exist on the lunar surface, and they don't need to be shipped from Earth at all. A lunar manufacturing base would mine and process those materials on-site. Energy for the operation comes from solar arrays deployed in lunar orbit or on the surface, or from the nuclear power systems currently in active development specifically for lunar applications. The decisive advantage of manufacturing on the Moon is not the resource access alone. It is gravity. Lunar surface gravity is approximately 1/6 that of Earth. A mass driver, an electromagnetic launch rail built along the surface, can accelerate hardware to lunar escape velocity, using a fraction of the energy required for a chemical rocket from Earth. Satellites manufactured on the Moon can be deployed into cislunar space without a single kilogram of chemical propellant. This means the full orbital infrastructure, AI compute nodes, communication relays, power arrays, could eventually be produced and launched entirely from the lunar surface. Earth-based launches become the supply chain for the initial construction phase. The Moon becomes the permanent factory. The foundational technologies for this system, resource extraction at scale, additive manufacturing in vacuum, electromagnetic launch, are in active development right now. The missing element has always been economic justification. AI infrastructure revenue provides that justification at a scale no previous space application has ever reached. The global AI infrastructure market, data centers, compute, cloud services, is already measured in the hundreds of billions of dollars annually. Analyst projections extend it toward tens of trillions over the next 2 decades as artificial intelligence embeds itself into every sector of the global economy. SpaceX's orbital compute network would not need to capture the entire market. It wouldn't need a majority of it. Even a single-digit percentage of a multi-trillion-dollar market generates revenue sufficient to fund the Mars program independently of any government contract on any timeline. This is the internal logic of the strategy. AI services generate recurring revenue at scale. That revenue funds Starship development and production rates. Production rate Starship builds out orbital compute capacity. Orbital compute generates more AI revenue. A consistent portion of that revenue, reinvested across decades, finances the Mars mission. No single government as primary client, no dependency on political cycles. No program cancellation tied to election outcomes or shifting public priorities. A self-reinforcing economic engine running on the most valuable commodity of the 21st century, machine intelligence. The Mars city doesn't get funded by taxpayers. It gets funded by AI services running on hardware SpaceX put in orbit, manufactured on the Moon, launched by a mass driver, and operated by autonomous systems that SpaceX also runs. That is the plan. And unlike previous visions of space colonization, this one has a business model attached to it. Every civilization in history has expanded by finding resources beyond its current boundaries and building the logistics infrastructure to access them. The technology changes across centuries. The pattern never does. SpaceX is not building rockets. It is constructing the infrastructure layer for the next phase of human civilization, one in which the resources of the solar system become accessible and the constraints of a single planet stop defining the ceiling of what humanity can achieve. Artificial intelligence is not a detour from that mission. It is the economic engine that makes it viable. The profits from orbital compute fund the lunar factory. The lunar factory builds the next generation of orbital hardware. That hardware generates more revenue, and that compounding return, sustained across decades, finances cities on Mars, and eventually, permanent outposts deeper into the solar system. The future of space is not written in rocket exhaust. It is written in data, in the quiet hum of orbital servers processing queries from Earth, while the humans who built them prepare to live somewhere else entirely. If this video changed how you see the space economy, or how you see SpaceX, drop a comment below. I want to know. Does this AI strategy actually get us to Mars? Or is there a flaw in the model that nobody's talking about? Your comments shape what we cover next on this channel. I read every response. If you found this channel for the first time today, subscribe now. We cover the systems and technologies shaping the next century, from space infrastructure to quantum physics to the deep science behind breaking events, and we don't simplify the hard parts. The next video in this series goes even deeper into the orbital economy. Don't miss it.